another one, and another one. Yeet, why you all in my ear talking a whole bunch of
As you may know, I'm Albert Einstein, and I made a discovery that will blow your mind! And that is that space is curved, you know. And this is one of the wackiest ideas in modern science, yeah? In fact, it is too wacky for our teeny tiny human brains to comprehend in its 3 dimensions. 3D. So, in order to understand it, we simplify it to 2D. Here is a little ant. We are like this little ant exploring its 2-dimensional space. Because we can't quite fathom the curved space in its 3 dimensions, we simplify it to the next easiest dimension for us to understand, and that is 2D. Now check this out! According to my equation, all space is curved because matter tells space how to curve, and, well, as there is matter everywhere, space is curved everywhere. Whoa! And if space is curved, then some of the stuff that we learn in school is wrong. Oh my god! The geometry that we learn in school was invented over 2,300 years ago by some guy named Euclid. He's a Greek mathematician, you know. This geometry was based on the old schools of thought that space was like an intangible grid, much like those in a street directory. But now that we know that space is in fact curved, Euclid's geometry is only relevant in our simplified 2D understanding. Boy, that was a mouthful. Now, let's see how all this craziness can be explained using the spherical whiteboard. As I make triangles bigger and bigger, the sum of their angles increases from 180 degrees to 270. Pythagoras' theorem goes wrong. Now, with a right-angled triangle, we all know the formula is a squared plus b squared equals c squared. But with this right-angled triangle, the formula is incorrect. In fact, it changes to a squared plus b squared equals 2c squared. Near a black hole, space is curved like this. Now this doesn't just occur because there's a crazy person on the other side. This gravitational lens is designed to replicate the effect a black hole has on light. This is due to the fact that near a black hole, light becomes distorted. And this is because that not even light can escape the pull of a black hole. Here's another cool example. The lens is distorting the light, allowing the light to bend in different ways, forming cool patterns. I love patterns! Now, as light is the straightest thing we know, and even that becomes distorted in curved space, then this applies to all straight lines. They better watch out. And you know what that means, right? Am I right? You don't. Well, because straight lines may become distorted, this also means that parallel lines may become distorted. This distortion allows intersection of parallel lines. But you didn't see that one coming. Look at this! These two cars are traveling on parallel straight trajectories. But as they approach the black hole, their straight paths become distorted, and their straight paths actually intersect. This shows that in curved space, parallel lines may actually intersect. A quick recap of some of the things that we have just covered.
heads up, heads up, heads up, heads up, heads up, heads up.